Okay, welcome back to our programming videos. This is the last thing that we did, and this was assigned for your homework. So let's continue from here. Let me just review here, working with Visual Basic operators, and we've been talking about these operators. We also had this one, which we haven't used in a form yet, this one, and this one. So we want to use those now. Let's just see what they say here. A formula is a statement that combines numbers, variables, operators, and keywords to create a new value. Okay, so we might have numbers in a formula, we might have variables in a formula, we might have operators, these operators, and keywords. Those are just Visual Basic programming words to create a new value. Visual Basic contains several language elements designed for use in operators. In this section, you'll practice working with arithmetic or mathematical operators. So these are operators. The symbols used to tie together the parts of a formula. With a few exceptions, the arithmetic symbols you'll use are the ones you use in everyday life, and their operations are fairly intuitive. You'll see each operator demonstrated in the following exercise. So we saw in your homework these first four demonstrated. And here's the kind of thing that you would have done. So first of all, they declare some variables as doubles. So that means that they can take on virtually any number we might need. Decimals and large decimals and large numbers. And then we assign to the first number whatever appears in our text box 1 text, and whatever appears in text box 2 .text gets assigned to the second number. And then we have four if statements here. If and if and if and if and if. And what they say is, what the first one says is, check to see if the first radio button is selected, meaning if this radio box is checked or selected. Then what do we want to do? Well, that was addition. So what we want to do is we want to take the value in text box 1 and add it to the value of text box 2 and put that in our result text box, which is here, and that's the third text box. So we'll say first number plus second number equals the result, or equals what goes into text box 3.text. On the other hand, if it's not radio button 1 that's checked, but if it's radio button 2 that's checked, in other words, if that checked property is true, then we'll do this, which is we'll do minus. If the third button is its checked property is true, then we'll do times, and then if not, then if this one is true, then we'll do division. And so that's how we accomplish this part of our calculator. Okay, let's take a look at this. This is called shortcut operators. And we have this here. And what does this do? What does that do? Well, remember, it doesn't make sense if you think of it as equals in like mathematical sense. You can't say x equals x plus 6. Mathematically, it doesn't make sense. But it doesn't mean equals, as we've said. It has a different meaning. It means assigns, even though we might read it as equals because it's an equal sign. At least mathematically it is. But even though we might read it as equals, it really doesn't mean equals. It means assign to. So what does this mean? It means that if x was 5 before, then x will become 11, because we'll take 5 plus 6 and it will become 11. What does this mean? If x was 5 before, then what the new x will be 5 minus 6, or negative 1. If x was 5 before, the new x will be 5 times 6, or 30. So the new x will be 30, and so on. Okay, so these are, we've done these. This one, this is regular division, and this is called integer division. I think in a previous video I said it was mod, but it's not. It's integer division, and it means, well, let's see what it means. Let's look it up. I looked at mathworldwolfram.com, and integer division. So if we have 10 divided by 3, of course the answer is 3 1/3. But integer division will give us 3. In other words, the fractional part, the 1/3, is discarded, and we just have the 3 left over. So we discard the fractional part. We drop the fractional part. So that will be this, integer division. We also have exponentiation, and we have string concatenation. Alright, now, so we are familiar with these. Over here, this is just a short way of writing this. And so this means this. It's just another way of writing it. This means this. This means this. And the way this is read is x plus equals 6, x minus equals 6, x star equals 6, x / equals 6, and so on. So what does this mean? It means that you're going to reassign x a new value, just like we're doing here. We're reassigning x a new value. And what are we doing? We're adding 6 to it. So this means add 6 to the new value of x. This means subtract 6 to the new value of x. This means multiply 6 to the new to get the new value of x. I shouldn't say to the new value of x, to get the new value of x. This means divide by 6 to get the new value of x. Integer divide x by 6 to get the new value of 6, and so on. Okay? So these are just short ways of writing this, so they just mean exactly the same thing. Okay, whether you want to use these or not, whether you like using these or not, you should get used to them so that if you see them, because you will see them written by other people, you'll know how to understand them. Okay, so let's build the same kind of calculator for the so-called advanced operators. This is integer division. This is mod. This is concatenation, and ampersand. So we want to build basically the same thing, but with these new operators. So as part of your homework for this week, please build this one and submit it as a separate form. In other words, for in your homework, you should make separate forms. So here's one, and there may be others as we go through this video. There may be other homework assignments, and you should submit each one separately, but put them all into one folder. Give it the appropriate name with your ID and student name and so on, and zip it, and then upload that. But it will contain a number of different solutions. So here to review, integer division produces only the whole number result of the division operation. Although 9 divided by 2 equals 4.5, the integer division operation returns only the first part, an integer, the whole number, 4. He says, you might find this result useful if you're working with quantities that can't easily be divided into fractional components, such as suppose you want to know the number of adults who can fit in a car. You don't want to say 4.5, you'll say 4. And just to review the mod operator, if we're doing that, we get the remainder, or the part left over, after the two numbers are divided. So, for example, if we had 9 divided by 2, 9 mod 4, 9 mod 2, the answer would be 4. Let me say this again. The answer would be 1, because that's what's left over. So 9 equals 2 times 4, plus 1. So if we did 9 mod 2, it would be 4 plus 1 as the remainder. So the answer for mod would be 1 in this case. Now they say to explore the concatenation operator, click on that radio button, and let's see. Suppose we put 9 and 2 into the two text boxes, as in this picture. So we have 9 and 2, but we click this button instead of this. So what are we going to get? He says, and you'll see, that the number 92 appears in the result box. The string concatenation operator combines two strings in a formula, but not through addition. The result is a combination of the character 9 and the character 2, not the numbers 9 and 2. String concatenation can be performed on numeric variables. For example, if you're displaying the inning-by-inning score of a baseball game, as they do in the old-time score boxes. But concatenation is more commonly performed on string values or variables. So usually we don't use it for number concatenation. Now he reminds us that we declared first number and second number. Those are the two variables we declared. We declared them as doubles. So we may encounter a problem if we try to use the concatenation operator when we're using text, which is normally what you would use it for. So he says, try typing in birth in the text box 1 and day in text box 2, and see and verify that the concatenation operator is selected, and then click the calculate button. And it says Visual Basic is unable to process the text values you've entered, so the program stops running and an error message appears on the screen. So you'll probably see an error message like this. It says invalid cast exception was unhandled. Then it says conversion from string birth to type double is not valid. Remember, birth that we entered in the text box is of type string, and it's expecting a double in the variable, and it's not able to convert that. Sometimes it will be able to make conversions, or it will guess at the conversion that you want, but it can't guess what to do, how to convert birth to a number. So it says conversion from string birth to type double is not valid. And then what else does it say? Troubleshooting tips. When casting from a number, casting means converting, the value must be a number less than infinity. Make sure the source type is convertible to the destination type. Okay, so let's see what he says. He says this type of error is called a runtime error. So it didn't happen when we tried to compile the program. Most of the errors that we've encountered so far are when we click run, and before we even are able to see the form in its user version, we get an error. But here we didn't have any such problem. We were able to run the program. But now when we actually try to so-called run it, when we actually use it, we're getting an error. So that's a different kind of error. So one is that the compiler, the part of the Visual Basic that takes our code and converts it into computer code, that's the compiler. That's one type of error, when the compiler can't even compile the program. But it was able to compile the program. You were able to try it, so it was able to compile it. But still, there's an error that occurs. We get this error, and that's called a runtime error. So it's a different kind of error, and you should understand the difference between those two types of errors. One is when you can't even compile it, and the other is when you've compiled it and you try to run the program, and then you get an error. It's called a runtime error. Okay, now, the compiler doesn't know that you're going to enter something as text when it's supposed to be numeric, and so it doesn't complain, and it compiles. But still, the program can't run because you're making that kind of error. Okay, so he says this type of error is called a runtime error, an error that surfaces not during the design and compilation of the program, but later when the program is running and encounters a condition that it doesn't know how to process. Okay? So here it says the computer speak, or the computer message, conversion from string birth to type double is not valid, means that the words you entered in the text boxes, birth and day, sorry, did I say that? We're going to type in birth and day, could not be converted or cast by Visual Basic to variables of the type double. Double types can only contain numbers. So he says that Visual Studio doesn't leave you hanging with such a problem, but tries to provide you with some information, a dialog box with different types of information to help you resolve the runtime error. For now, you have learned another important lesson about data types and when not to mix them. So you might try to discover, by doing a little research on the internet, how you could avoid this problem, but we'll do it later. Here at the end of this section, he gives us a tip. He says, runtime errors are difficult to avoid completely. Even the most sophisticated application programs, such as Microsoft Word or Microsoft Excel, sometimes run into error conditions that they can't handle, producing runtime errors or crashes. Designing your programs to handle many different data types and operating conditions helps you to produce solid, or what they call robust, applications. So robust means working in under many different conditions. In Chapter 9, Trapping Errors by Using Structured Error Handling, you'll learn another helpful tool for preventing runtime error crashes, the so-called Structured Error Handler. Okay, one more thing we want to talk about are some additional methods that we can employ because of the Microsoft.NET framework. And basically, these are the Microsoft.NET framework gives you a kind of extra libraries with extra code. So they have already written certain kinds of functions, and you don't have to write them yourself. You can use them. And the way that you would do that is something like this. There's a function called this. In other words, it calculates the square root, and you can use this to calculate square roots. So the way that you do that is, first you need to import what's called system.math classes, or system.math library. Okay, so at the very top of the code editor, above the public class form1 statement, you type this. And once you type this there, then you can access, for example, these functions. So if you want the absolute value, you can type ABS and the number that you're trying to get the absolute value of. If you want the so-called arctangent, you could use this. If you want the cosine, you could use this. If you want to raise e to a certain power n, you can use this. So this is basically e to the n. This returns the sign if n is less than 0, and it returns 0 if n is equal to 0, and plus 1 if n is greater than 0. And this is the sine function, and the square root function, we just saw that one, and the tangent function, among others. Again, though, you need to type this, imports system.math, at the very top of the code editor. above the public class form 1 statement, you type this. Now, by typing this at the top, it makes it much easier to make a reference to a function. So all you have to do is write square root. Otherwise, you'd have to write something very long. But you don't have to do that. You can just write square root because you type this at the top. Or maybe not that long, but still you'd have to type something like this, system math.square root. So instead of having to type that, you just have to type square root if you put this at the top. He says the import statement must be the first statement in your program. It must come even before the variables that you declare for the form and the public class form 1 statement that Visual Basic automatically provides. So it has to be above even that. One more thing. If you have a statement like this, the order that you do these operations in could make a difference. So I guess if you had 10 plus 15 and then you did that squared, I'm sorry, you did that times 2 and then divide that by 4 and then raise the whole thing to the second power, that probably is different than if you raised 4 to the second power and then divide that into this. Okay, so that the order that these operations are done will make a difference in terms of what total will be. But of course we don't want to have that. So either you have to use parentheses or you have to rely on the order of preference of the operations. That means you have to know which one will be done first, which one will be done second, and so on. So he says Visual Basic solves this dilemma by establishing a specific order of preference for mathematical operations. This list of rules tells Visual Basic which operator to use first, second, third, and so on. So of course if you want to rely on that, you have to know the order. So here's the order of preference. So you can override anything with parentheses. In other words, what's surrounded by parentheses will be done first. The next thing that will be done in the expression is exponentiation, this one. So that will be done next. So up here, it won't be that we do all of this and then square it. It will be no. It will be that 4 is squared and then some other things will be done. The next operation will be, in preference, will be minus, creating a negative number. I'm sorry, that's not minus, that's creating a negative number. That will be done third. Multiplication and division are fourth. Integer division is fifth. Mod remainder division is sixth. And then addition and subtraction are last. So in that case, what will be done first? This will be done first, so this will become 16. And then what will be done next? So it won't be 10 plus 15 and then multiplied by 2. It will be 15 times 2, which gives us 30, and then add 10. And then it won't be add 10 to 30 and divide by 16. It will be 30 divided by 16 and then add 10. So this will be the result. However, you can use parentheses to change the order or to make it clear what the order is. Okay. We'll go on to chapter 6. Using decision structures. So this is like using if-then. And there's one other thing that we'll do that's related to if-then.